The T-14 Armata represents the latest iteration in Russia's pursuit of armored dominance on the modern battlefield. As a next-generation main battle tank, MBT, it boasts a host of innovations, many of which are touted by Moscow as revolutionary, though their true effectiveness remains a subject of debate. The T-14 is built on the Armata Universal Combat Platform, a versatile base designed to support a range of armored vehicles, underscoring Russia's ambition to modernize its ground forces. At its core, the T-14 features a fully automated and unmanned turret, a notable departure from traditional MBT designs. This turret houses a 125mm 2A82-1M smoothbore gun capable of firing a variety of ammunition types, including armor-piercing fin-stabilized discarding sabot, APFSDS, rounds, high-explosive anti-tank, heat, shells, and anti-tank guided missiles, ATGMs. The tank is also rumored to be compatible with vacuum projectiles, enhancing its penetrative power against contemporary armor. A 7.62mm PKTM machine gun serves as a secondary weapon, while an optional 12.7mm Cord machine gun can be mounted for additional firepower. The T-14's fire control system integrates advanced sensors, including a thermal imaging sight, a laser rangefinder, and a ballistic computer, which collectively aim to provide superior target acquisition and engagement capabilities. The tank is also equipped with an active protection system, APS, known as Afghanet, designed to detect and neutralize incoming projectiles before they can strike the vehicle. This system includes radar and a suite of countermeasures to deflect or destroy threats such as anti-tank guided missiles and rocket-propelled grenades. The crew, consisting of 3 members, commander, gunner, and driver, operates from an isolated, armored capsule in the front of the hull. This layout is intended to enhance crew survivability by physically separating them from the ammunition and turret, thus mitigating the risk of catastrophic losses in the event of a turret penetration. Measuring approximately 10.8 meters in length, including the gun, and with a width of 3.5 meters and a height of 3.3 meters, the T-14 presents a formidable profile. The tank is powered by a 1,500 horsepower 85.3A diesel engine, which purportedly enables a top speed of up to 75 km per hour on roads and a range of up to 500 km. The transmission is an automated type, facilitating smoother gear changes and potentially reducing driver fatigue during prolonged operations. The T-14's armor incorporates a blend of steel, ceramics, and composite materials, although the exact specifications remain classified. The tank's design philosophy appears to prioritize modularity, allowing for easy upgrades and maintenance. Russia claims that this armor configuration offers enhanced protection against kinetic and chemical energy threats, although such claims should be scrutinized given the limited combat exposure of the T-14 to date. Despite these advanced features, the T-14 Armata's deployment has been relatively limited, with concerns surrounding production costs, logistical support, and the actual performance of its novel systems under combat conditions. Russia's military-industrial complex has faced challenges in mass-producing this advanced tank, and it remains unclear whether the Armata will become the backbone of Russia's armored forces or if it will remain a symbol of technological aspiration rather than a battlefield staple. The T-14 Armata, heralded as a groundbreaking leap in tank design, has curiously remained on the periphery of active combat in the ongoing conflict between Russia and Ukraine. Despite the lofty claims surrounding its capabilities, the tank's limited presence on the battlefield has fueled widespread speculation about the reasons behind this decision. Earlier this year, Rostec's CEO hinted at the Armata's absence, stating that the vehicle is too valuable to risk in the theater of war. Subsequent reports from state-run TASS suggested that the T-14 had been deployed only briefly for experimental purposes, resulting in modifications based on these limited engagements. This conspicuous absence of the T-14 on the front lines raises several questions about its true effectiveness and operational readiness. Could the reluctance to field the Armata in greater numbers stem from production issues, prohibitive costs, technical shortcomings, or perhaps even doubts about its battlefield performance? One plausible explanation is rooted in the production and logistical challenges that have plagued Russia's defense industry. Manufacturing a next-generation tank like the T-14, with its complex systems and advanced technologies, requires a robust industrial base, which has been under significant strain due to international sanctions and economic constraints. The supply chain disruptions and the limited availability of critical components may have hampered mass production, leaving only a small number of units available for deployment. Cost is another critical factor. The T-14's sophisticated design, which includes an unmanned turret, advanced armor, and an integrated active protection system, APS, significantly drives up its production expenses. Each unit is estimated to cost several $1 million, making it one of the most expensive tanks ever produced. In a protracted conflict where Russia is facing attrition across multiple fronts, the financial burden of deploying such an expensive asset in large numbers could outweigh the strategic benefits. Moreover, the technical complexity of the T-14 might contribute to its limited use. The Armata platform introduces a suite of new technologies, including an entirely new engine and transmission system, advanced sensor arrays, and a high degree of automation. While these innovations promise enhanced combat effectiveness, they also increase the risk of technical failures and maintenance challenges. The harsh conditions of war often exacerbate these issues, potentially leading to higher than expected downtime and repair requirements. Performance concerns cannot be overlooked either. The brief experimental deployment of the T-14 in Ukraine may have revealed vulnerabilities or shortcomings that need to be addressed. Combat is the ultimate proving ground, and any deficiencies uncovered during these trials would necessitate further refinements before the tank could be deemed fully operational. This could include adjustments to its armor configuration, improvements to its fire control systems, or upgrades to its APS to better handle the threats it might face in the field. Strategically, deploying the T-14 in large numbers could also pose a significant risk. Losing even a few of these high-value tanks to enemy action or mechanical failure would not only be a material loss but also a blow to the prestige and psychological impact that Russia seeks to maintain. The decision to withhold the T-14 from extensive use might also reflect a more cautious approach by Russian military planners. The unpredictability of modern warfare, especially in a conflict characterized by a high intensity of artillery and anti-tank guided missile use, presents a formidable environment for any armored vehicle, regardless of its technological edge. In such a scenario, the emphasis may shift towards conserving the T-14 for scenarios where its advanced features could be deployed to their fullest advantage without undue risk. In summary, the limited deployment of the T-14 Armata likely stems from a confluence of factors, including production bottlenecks, cost considerations, technical teething issues, and strategic calculus. While the T-14 is undoubtedly a formidable piece of machinery on paper, the realities of war often differ from the controlled environment of a testing ground. Until these underlying challenges are fully addressed, the T-14 may remain more of a showpiece than a game-changer in Russia's armored forces.